This is a Unit 7 Part 2 practice problems review. So these practice problems are going to be the types of problems that you'll see on the quiz for Part 2 of Unit 7. All right, the first question says, are these two triangles identical? Explain how you know. So we're going to take a look at where the angles are and where the sides are. And if the angles and the sides are on the same spot, then they are probably identical. So we've got here angle 95. Here's angle 95. Then we have our angle 70. And here is the angle 70 on the other triangle. Then we've got the side that is 12 here and the side that is 12 here. So these triangles are not identical, and the reason that they are not identical is because on the first triangle, the side of 12 is adjacent, meaning next to the 95 degrees. So on the first triangle, the side of 12 is adjacent to the 95 degrees. We can see that right here. But on the second triangle, the side 12 is adjacent, meaning right next to the 70 degrees. So because the 12 is not adjacent to the same angle on each triangle, the two triangles are not identical. This next question is asking if these two triangles are identical and explain your reasoning. These questions on the quiz and on the practice problems, you need to be able to explain why. So that is an important skill. So we've got this green triangle here where its angles are 70 degrees, 7 degrees, and 40 degrees. Then we have this pink triangle, and its angles are also 70 degrees, 70 degrees, and 40 degrees. Now we need to decide, are they identical? They look similar, but are they identical? If I were to cut that little pink one out and place it on top of the green one, are they the exact same triangle? So let's do that. Let's actually try and cut them out. All right, so what I've done is I've cut out this green one right here. If I were to turn it and lay it right on top, let's see. It's hard to turn it without changing the size of it. There we go, we lay it right on top. Are they identical? Is it exactly the same one over the other? And the answer is no. The pink one ended up being smaller than the green one. So because of that, they are not identical. But there's an actual explanation that we can say to say why they are not identical. If two triangles have all the same angles, they are not identical because the lengths can be different. For a triangle to be identical, all the angles and all the lengths have to be the same. So if you have all the same angles, their lengths can still be different. So therefore, these triangles are not identical copies of each other. All right, question 3. Word-wise, this might be the most difficult one, but then actually being able to do it, it's a very simple problem. It says in the diagram below, so here's our diagram right here. The length of segment AB is 10. So here, that is 10. And the radius of the circle centered at A, so here's my center A, the radius, meaning anywhere out from there, is 4. We're going to use that information to create 2 unique triangles, each with a side of 10 and a side of 4. So if I go and I create one triangle, there we go. That is one of the triangles. If we were to cut that out, there's one triangle. I'm going to just call it triangle 1. And then I could also maybe have a radius like way out here. And that would give me another triangle. There we go. That is triangle 2. It's important to note that there are 2 different triangles. We've got this. If we were to measure the angles of each of these, they would be completely different angles there. So that's it. 2 separate triangles. You just have to show that you can make 2 separate triangles by taking the radius out and then connecting the end of the radius all the way to point B. This will be another problem where you need to do it on paper and take a screenshot of it and submit that way. All right, this question, a very simple question if you know what to do. Select all the sets of the 3 side lengths that will make a triangle. So if we start with this first one, the rule is the 2 small sides added must be greater than the largest side. So let's look at this first one. My 2 smaller sides are 3 and 4. So is 3 plus 4 greater than 8? 3 plus 4 is 7. 7 is not greater than 8. So this is not a triangle. Let's look at the next one. We're going to take the 2 smallest sides, which is 7 and 6. Is 7 plus 6 greater than 12? 7 plus 6 is 13. 13 is greater than 12. So this is one of our solutions. It does make a triangle. The next one, 5 and 11 are the 2 smallest sides, so 5 plus 11 is greater than 13. Is it? We're not sure. Well, we can go 5 plus 11 is 16. 16 is greater than, 13. So this would definitely be a triangle. The next one, 4 and 6 are my 2 smallest side. Is that greater than 12? Is 10 greater than 12? It is absolutely not greater than 12, so this would not be a triangle. Now the last one here, this is our tricky one. It is 4 and 6 again, but is 4 plus 6 greater than 10? 4 plus 6 is equal to 10. Is 10 greater than 10? It is not. If it were greater than or equal to, but since it's just greater than, this is not a triangle. All right, here is our application question. It's kind of a nice real-world situation, but it says, based on a signal strength, a person knows their lost phone is exactly 47 feet from the nearest cell tower. So here's their phone. Here's the cell phone tower. Okay. They know that their lost phone is exactly 47 feet from the tower. The person is currently standing 23 feet from the same tower. So here is our person. Okay. We know that the person is 23 feet away. Now, they could be there, but there's other places they could be, not just in between the phone and the tower. The closest the person can be to the phone is whatever that distance is here. So the closest they could be is 47 minus 23, which would give us 24 feet. So the closest the person could be is 24 feet, because that means they are in between the phone and the tower perfectly. The next question says, what is the furthest the phone could be from them? And let's take a look here. If I move my person over, let's get rid of them here, and here, and here, and let's move them away from the tower. So let's say they're still 23 feet away from the tower, but now they're on the other side of the tower from the phone. This is the furthest away they could be. We want to figure out that distance. That would be 47 plus 23, which would be 70 feet. So the closest they can be from their phone is 24 feet. The furthest they could be is 70 feet. And that is it. This problem, though it's kind of hard to see, is almost identical to the problem with the circle and the diameter where you had to create the triangles. Because our person could be like 23 feet away here and be that far away from the phone. But this is the closest and the furthest that they could be. All right, this is our last question on here. This one's also one where you're going to have to write something down. But it says, a triangle has one side that is 5 units long. So here's our 5 units long. And an angle that measures 25, and it's adjacent to that angle. There are 2 other angles in our triangle. One of the angles is 90 and the other is 65. They want you to write 2 diagrams to create 2 different triangles. So I'm going to cut these 2 out. So here is my one triangle, and here is my other triangle. And I'm going to create 2 different triangles for these. We do know a couple things. We know that the measures of the other 2 angles has to be 90 degrees and 65 degrees. So a 90-degree angle is a right angle, and that's very helpful in solving these problems. So if I look at my first one, and I make this a 90-degree angle, then that means this angle is 65 degrees. So there's one of my triangles that can be made with the 90-degree angle and the 65-degree angle. You're going to actually have to draw that and show it. The other triangle that can be made is if instead of making this angle 90, I make this angle 90 degrees. And that would make this angle 65 degrees and this 90, and that's just a little bit different triangle. It makes, instead of the angle adjacent to the 5B 90, the angle opposite of the 590. And there are my 2 triangles that can be made with a side of 5, adjacent to an angle that's 25, and my other 2 angles being 90 and 60. And we just switch the other 2 angles up, one being 90, the other being 60. Okay, that is it for the part 2 practice problems. Good luck studying and good luck on the quiz.